Hello everybody, welcome back. One last time for looking at trig functions. We're going to now solve for the adjacent side of this triangle. In the last video we solved for the opposite side. So now if we're going to use a trigonomic function to solve for the base of this triangle, again I got to go back and look which trig function based on the values that I've been given do I want to solve for. If you were following along in that last video and you have the number, this was 26.450, roughly the vertical component of that triangle. If you have that value and you're starting to feel comfortable, what I would encourage you to do is don't follow the specific method we use. Maybe use tan or use Pythagorean theorem to come up with the horizontal component. See if you're starting to grasp this concept. If you can come up with that equal magnitude in a different way that we have, that's fantastic. So what I would encourage you to do is pause the video, try and solve for this value ahead of me, and then as I walk through this, make sure that we're following the appropriate steps and we come up with the appropriate answer in the end. So now I need to pick, I'm going to solve for the adjacent side of my triangle. So I still have a magnitude of my hypotenuse is 45 volts in this case. At an angle of 36 degrees, I will have a horizontal component of this triangle, which I'm going to call my adjacent. This side of this triangle has been given an adjacent name because it is directly beside the angle that's been given. So I have to pick my trig function. Okay, tan theta for right now doesn't work because I have a hypotenuse, and I'm also looking for adjacent. I'm looking for the adjacent, but I don't have the hypotenuse, so I'm missing too many variables. I'm actually missing two variables in this one, so I can't use it. Cos theta, well, I have a hypotenuse, I have an angle, and I'm looking for the adjacent. So I have these two variables, I can use cos theta. Just to double check, sine theta, that's what we used in the last one to solve for the vertical component, so we know we're not using that one. So cos theta, that's the trig function I'm going to use. So cos theta is equal to my adjacent over my hypotenuse. So now I have to transpose this formula. So adjacent is being divided by hypotenuse. Opposite of division is multiplication. So you multiply this side. What I do to one, I must do to the other. These cancel. That was why we performed that opposite function. And I am left with hypotenuse, which is equal to the cos of my angle will equal my adjacent, which is what I'm looking for. So now I substitute these values, and I just wrote equals there. How about we do this correctly? We say hypotenuse times the cos of the angle is equal to the adjacent. That's my mistake. So we have 45 volts times the cosine of 36 is going to equal my adjacent. And this adjacent value should be 36.405, roughly, is going to be the magnitude of that adjacent value. So I hope this has helped, and these have to show us how to come up with each of the sides of my triangle based on the trig function that I've been given. And like I said, if you can now take these values and just remanipulate any one of these formulas and see if you can kind of reverse engineer to make sure that you can solve for any of the sides of the triangle by what's been given. I hope this has helped, so see you in the next one.